Right. Hello, everybody. Welcome to our monthly demo for Portworx enabling hybrid cloud with EKS Anywhere in Portworx. We're just going to give a couple minutes for some more attendees to filter in, and we will get started shortly. Okay. So welcome, everybody. Good morning, good afternoon, good evening, depending on where you're at. My name is Tim Darnell. I'm a senior technical marketer for the Portworx team here at Pure Storage. Today we're going to talk about and show you some demos around EKS Anywhere with Portworx. If you're not familiar with EKS Anywhere, it's essentially a vSphere hosted on-prem version of Amazon's EKS, which is the managed service that a lot of us use to run Kubernetes on EC2 infrastructure in AWS already. Portworx has been supported as a storage solution for quite a while now within EKS on AWS. So before we dig in too much about EKS Anywhere, let's just review a little bit about the benefits, and I want to kind of lay the foundation that you end up getting when you're using the Portworx data platform in EKS on AWS. So why Portworx plus EKS? We provide some major benefits for data and applications running inside EKS that the standard EC2 plus EBS volume infrastructure just really can't provide for your stateful applications and workloads. Cross-region migrations are really simple when you use Portworx, and they're easy using PX Migrate, which is actually the technology that I'll be showing in one of our demos today. Keep in mind, we're migrating full stateful application data along with the applications and services and all of the other Kubernetes objects associated with that data. So, we're not just a PVC backup restore where all you're actually expected to recreate all of the other associated Kubernetes objects by hand, like some of the other solutions. We're actually going to take everything that's within that namespace, the applications, the stateful sets, the deployments, your services, all of that gets migrated with our PX Migrate solution. Cross Availability Zone HA is another really big benefit that you get when running Portworx as your underlying storage engine for EKS. Without Portworx, EBS volumes are obviously going to be tied to a specific availability zone, and you're actually responsible for finding that solution for replication across those availability zones to prevent outages in the case of a AZ or a region failure. Uh, with Portworx, we can simply just create our storage cluster that spans across those multiple AZs, and we can automatically replicate those volumes across those availability zones. And that provides fast failover for applications in the case of a zone or a region failure. When you add in our volume placement strategies, you can really have pretty flexible and granular volume placement to ensure either co-location of volumes or replicas or separation of volumes and replicas. And you can meet your application fault domain or performance needs using those volume placement strategies. Backup and DR can also become really simple compared to other solutions with Portworx running on EKS. And this is thanks to our PXDR and PX backup pillars within the Portworx data platform. PXDR enables both asynchronous and synchronous replication capabilities. And when you're doing sync, we offer a 0 RPO solution. And PX backup enables really any cluster anywhere backup capabilities. And we can store those backups on any S3 compliant bucket across the globe for quick restoration of full namespaces, all of your applications, services, and all of their associated data. So the last kind of point I want to touch on here is Portworx brings good security, compliance, and optimization capabilities to your Kubernetes environment as well. We allow for true token-based RBAC granularity for enabling security and access to your underlying storage infrastructure. And that's achieved using our PX Secure product. Finally, PX Autopilot is able to automatically monitor and dynamically grow your underlying PVs when you might have an application that's growing quickly. Autopilot can prevent your application from actually going down, due to a simple condition of running out of available disk space if it's growing too fast. So let's just recap real quick on those foundational pieces before we move into the EKS Anywhere and talking about the hybrid cloud functionality. So availability and scalability are increased considerably when you're using PX Store as a foundation for your data in EKS. Multi-zone DR with 0 RPO is possible using PX DR, and operational management is really simplified and centralized, no matter what regions or outposts you might be using within AWS. Cloud drive provisioning and PX Autopilot enable cost optimization and ensure that you'll never run out of available disk space for your applications, which leads to downtime. And our PX Migrate technology, which again we'll show you today in our demo, allows you to provide not only data portability, but full application and Kubernetes object portability between your Kubernetes clusters, regardless of location and your infrastructure platform. Our Kubernetes data protection product, PX Backup, lets you back up and restore all of your applications and data as a single object and can place those backups in any S3 compliant bucket on the globe, whether it's on-prem or in the cloud. So, all right, so let's get into the meat of the hybrid cloud. So similar to how Portworx can remove challenges from a standard EKS and EBS deployment, we can also break down some of those barriers and challenges that you have when you're attempting to create kind of that hybrid cloud scenario when you use EKS and EKS Anywhere together. So, one of the biggest challenges I think is the underlying storage when you're trying to use these two EKS platforms together. EKS, obviously, storage is provided by the underlying EBS volumes. And EKS Anywhere, since it's vSphere based right now, all of that storage is provided by the vSphere CSI driver. So this difference really has some knock-on and domino effects when you're trying to create solid hybrid solutions between EKS and EKS Anywhere. Operational management could be another big challenge you run into. You know, you need to have multiple methods, soft resources, staffing, technologies to keep track of by not having that single operational model to maintain for your underlying storage between all of those environments. And again, similar to just a standard EKS environment, that DR and data portability, data protection challenges, those can really be amplified due to the underlying storage not truly supporting all of the same Kubernetes primitives like a native Kubernetes snapshot. So again, you know, you kind of notice some of these same challenges exist in these hybrid scenarios that you may be looking at that exist with the basic EC2 and EBS deployments within AWS as well. So let's take a quick look at the EKS Anywhere deployment workflow and architecture before we kind of dive into this first demo. Excuse me. So this is the basic installation workflow and architecture that you'll see in a recommended EKS Anywhere deployment. You know, the only thing that is not recommended here, obviously, is a single etcd and single control plane. But for this demo purposes, we just deployed one of each there. So, you know, if you're familiar at all with any other on-prem Kubernetes platforms, you know, OpenShift, things like that, this should feel very, very similar or familiar to you. We'll start out with the admin workstation, which is capable of running that initial Docker image, and we'll stand up that simple Bootstrap cluster. The cluster API management gets instantiated on that Bootstrap cluster, and then we'll generate our YAML config that actually defines the management cluster. And once we initialize that Bootstrap cluster running on our admin workstation, the EKS Anywhere management cluster gets initialized. So the Bootstrap cluster, again, provides that initial cluster API management resource that'll be used to initialize the management cluster. And once that occurs, the cluster API management resource can get transferred over to that management cluster, and then the Bootstrap cluster gets shut down and destroyed. So once the management cluster is up and running, we can generate the YAML for our actual workload cluster. And there we'll define the size and types of the VMs that we want to run as our control plane, our etcd, our worker nodes, and we can define all of the vSphere information, such as the template to use, the data store, the network port group to connect the nodes to, and any other resource pools or inventory folders that we want to use in the underlying vSphere infrastructure. So once that workload cluster gets deployed, we can follow that standard procedure to deploy and configure our Portworx storage cluster on our worker nodes. And we're going to do that by going to PX Central, generate a spec. We'll then install our Kubernetes operator onto that workload cluster. And we'll go ahead and apply our storage cluster spec to deploy Portworx. Now, in this case, we're going to use a feature that we have called vSphere Cloud Drives. And what that's going to do is it's going to automatically provision the underlying VMDKs to be used as data drives for our Portworx storage cluster. And what that does is it makes sure, you know, it's very simple. We just define the size of the drives and the spec that we want to use. We provide a secret within Kubernetes so that Portworx knows how to go out, talk to vCenter, and provision those specific VMDKs. So there's no manual provisioning of storage necessary. It's really quick and easy and simple. So let's go ahead and take a look at a demo, and we'll go ahead and show you this installation process. So EKS Anywhere comes with EKS Cuddle Anywhere commands. And so very similar to the standard EKS Cuddle that you're used to with the EKS cluster and AWS services. So we're going to take a look at our management YAML here. And this is going to be, again, for creating that management cluster. This should look very similar or very familiar to you if you've stood up a Kubernetes cluster on-prem before. Again, we specify all of our networking. We tell it which data center within vSphere that we want to deploy to, how many etcd machines that we want, the version of Kubernetes that we want to deploy. You can see here that we're using the Tanzu Infra 1 data store, a 25 gig disk. We're going to deploy into the EKS VM folder, and we're going to have 2 CPUs and 8 gigs of RAM. So once we've deployed, or once we've configured that YAML, we simply just do an EKS cuddle anywhere cluster create, and we're going to point it to that YAML file that we just created. So here, very simple, it's going through connecting to vSphere, validating all of our resources within vCenter, making sure that the network's there, the data store's there, making sure any folders are there. And here you can just see the resource pool that we're going to be deploying into. You can see the actual folder itself that we're going to be deploying into. You can see the 2 Ubuntu EKS template VMs that we've downloaded and published to our content library. There's our Tanzu Infra 1 data store that we'll be deploying all these to, and the VM network port group that we defined within our YAML file. So creating the Bootstrap cluster right now, again, that's on our admin workstation, and then it's going to go ahead and deploy that workload cluster, which in this case is a management cluster. And then it's going to move that cluster API management resource from the Bootstrap over to our management cluster. Once that's done, we'll see it destroy that Bootstrap cluster, and now we have our management cluster up and running. So our next step is going to be to define that actual workload cluster, which is going to contain our worker nodes that we're going to deploy Portworx onto. So again, we're just going to define everything via YAML, define everything that we need for our workload cluster. We're going to name this guy W-01 or W01-PX. We're going to point the control plane to our existing management cluster. And again, we can have different virtual machine configurations for both our control planes and our worker nodes. So, keep in mind that you can kind of customize all of the vSphere machine configs depending on what type of nodes that you're deploying within this workload cluster. So again, we're going to run a EKS cuddle create cluster. And we're also going to point the kubeconfig to our management cluster that we just deployed. Okay, so very similar process. It's going to go out, connect to vSphere, validate all of the information that we've provided in the YAML file, and it's going to go ahead and go out and deploy those nodes and create our workload cluster for us. So the next step that we need to do is we're going to go ahead and just connect to this guy, export our kubeconfig, make sure that all of our nodes are there, they look good. Okay, so we've got healthy nodes, 3 of our worker nodes, and we can see that all of our core pods are up and running. Now, one thing we need to do is we need to create a secret for Portworx to speak to vSphere for our vSphere cloud drive. So we're going to go ahead and apply that secret. And when we go into PX Central to actually generate that spec for installing Portworx, we're going to reference that px-vsphere-secret whenever we generate the spec, so that when our storage cluster gets created, it knows how to talk to our vCenter. So here we've got PX Central, where we're actually telling it, hey, we want to go deploy Portworx version 2.9. We're going to tell it that this is a cloud installation. We're using a vSphere provider, and we want 150 gig disks for our data drives. We're providing it our vCenter endpoint, our port, and the data store that we want to deploy. And you can see there the secret that we populated within the spec. So we're going to go ahead, finish up this spec generation. And then we're going to grab the command to install our Portworx operator. So that's the first thing that we've got to do here, is go ahead and deploy our Portworx operator into our EKS Anywhere cluster. We'll wait for that pod to come up. Okay, that's running now. So now we can go ahead and apply our Portworx spec, and that's going to go through and create our storage cluster. Okay, so we've created our storage cluster. We need to wait for all of our associated pods to come up for the storage cluster here. And again, part of this process is Portworx going out to the vCenter. And for the worker nodes that are getting Portworx installed on them, it's auto-provisioning via our vSphere Cloud Drive feature those 150 gig disks, or VMDKs, that will be attached to these Portworx storage nodes dynamically. So again, all we had to do was supply that spec, apply it in Kubernetes, and it's going to go out and auto-provision those data drives for us. So you can see here there's a 150 gig drive on one of our worker nodes. There's another worker node, 150 gig drive. So again, the vSphere Cloud Drive feature is very powerful, makes it super simple to deploy out a Portworx storage cluster without having to manually provision the underlying storage resources. Okay, it looks like our cluster's coming up. Almost all of our pods are started here. So let's go ahead and exec into one of these pods, and we're going to issue a pixie-cuddle status to go ahead and look at the status of our storage cluster. And there we go. We've got 3 storage nodes up with 150 gigs each and a 450 gig pool to use for our underlying storage cluster. So that's how simple it is to go ahead and install EKS Anywhere and get Portworx up and running on the underlying storage. So let's go ahead and start my video again here for you guys. So let's talk about using PX Migrate. So now that we have Portworx installed on our EKS Anywhere cluster, and we've got another cluster out in the cloud on AWS that we're going to use, we're going to install an application within that on-prem data center EKS Anywhere cluster, and we're actually going to migrate the full namespace, and that includes all of the pods, any services, the PVCs, the stateful set and the deployment over to the EKS cluster that's actually running in the public cloud. So to do this, what we do is we create what's called a cluster pair within Portworx. And that essentially links these two Portworx storage clusters together. And then we can create what's called a migration spec, which defines the namespace and all of the associated objects that we actually want to migrate from our EKS Anywhere cluster over to our EKS cluster running in the AWS cloud. And keep in mind that this is not just a one-way operation. You know, if we wanted to use PX Migrate to migrate an application from AWS into our on-prem data center, we could do that too. So, you know, we've just chosen for this video or for this demo to actually show on-prem to public cloud migration. So let's just take a look at that and let's see how that goes. So here we're on our EKS Anywhere cluster. You can see we've got Portworx installed. We'll go ahead and do a pixie cuddle status, show that Portworx is healthy. We've got our 450 gig storage pool again. And we've already deployed a Postgres database within our demo namespace. Okay, so this is just a Postgres deployment using a replica set, and it's got 2 PVCs bound to it. Okay, so let's go ahead and exec into that Postgres pod. And we just want to show you that we've pre-populated some data into the database here. I need to use that demo namespace. There we go. So if we take a look at the underlying Postgres database, you can see that we've got 50 rows in our database here. Okay, so keep that in mind because we're going to want to remember that once we migrate things over to AWS. So let's take a look at all the resources in that demo namespace. You can see the pods, we've got a deployment, and we've got a replica set. So here's our AWS cluster. Okay, so if we take a look, we can see that we've got Portworx installed here. We're going to go ahead and exec in to one of the Portworx pods, issue a pixie cuddle status, show that we've got our Portworx cluster up and running and healthy here. Okay. So again, the first thing we've got to do is create that cluster pair, and that's just done with a simple YAML. Okay, so this essentially pairs these two clusters together, and we're going to be targeting that demo namespace, okay, because that's where our application is running. So we'll go ahead and apply that and create the cluster pair, and we can make sure that cluster pair was created. And then we'll issue a stored_cuddle get cluster pair to make sure that it's ready to actually perform a migration. Now, the migration YAML is what's actually going to define what we want to migrate. So again, you know, we're targeting that demo namespace. We're telling it to use the cluster pair, EKS cluster pair, which we just created. And we're telling it to include all of the resources within that demo namespace, and we want it to actually start up the applications and all of the resources once everything's migrated. So we'll go ahead and apply that migration YAML. And then we can check on the status of the migration using stored_cuddle. Okay, so you can see here that it's in progress. We're replicating 2 volumes, and it's in progress on one of those volumes right now. So if we go ahead and watch this via store cuddle, you can see one volume's already done. It's on the second volume. Now note that resources is at 0 of 0 right now. Now you're going to see that number change once the volumes are completely migrated over, okay? So we'll wait for this. Okay, so we've got both of our volumes migrated, and it's now at the application stage of the migration. So again, demo namespace is empty over in AWS. That's going to change here really quick as those resources actually get migrated over. And there we go. We can see our Postgres pods got created. It replicated our deployment and our stateful set. And now we can see that that migration is successful and it's in a final stage, which means it's complete. So we can take a look at some of the underlying resources on the AWS cluster. And we can see both of our PVCs were migrated over, along with all of the other resources that were associated with that application in our demo namespace. So here's the test, right? So let's go ahead and exec into our Postgres pod and see if we see those 50 rows worth of data. There we go. All right, so again, that PX migrate functionality gives you the capability to, take all of those Kubernetes objects and resources, not just the PVCs or the data, and migrate that to another cluster in order to make sure that you're able to get that full application backup, okay? All right, so you've just seen how easy it is to kind of create that true hybrid cloud scenario for your applications using Portworx as that underlying data platform for your EKS Anywhere or EKS clusters running on-prem and in the AWS cloud. So before we end our session today, I just wanted to take a look at a couple of other use cases that might interest you in terms of hybrid cloud functionality. One is using our PXDR technology, and for on-prem to AWS cloud, you're gonna need to use our asynchronous DR capability through PXDR. And again, what this does is this allows you to do very similarly to what you saw with PX Migrate, okay? Synchronizing the entire state of that application, all of the data, all of the services, all of your application pods, your PVCs, between those clusters. And you can actually set up a schedule for all of that asynchronous replication traffic. And then whenever you need to perform a cutover, it's really fast and really quick. You can use our synchronous technology with EKS, but due to the fact that if you're familiar with like Metro DR synchronous replication, we require certain latencies, certain amount of bandwidth between those source and destination clusters. So what we're seeing some of our customers do for synchronous DR is actually set up synchronous DR using PXDR in region to region within the AWS public clouds. So that way, if you do have a region failure, you actually have a 0 RPO solution for Kubernetes and your applications running there in the case of a public cloud region failure within AWS. So that's one of the examples. And then again, if you have any other on-prem Kubernetes infrastructure that you want to get into EKS, or you want to transfer into EKS Anywhere, as long as you have Portworx Enterprise as that foundational level for your storage cluster, you're able to use PX Migrate, and you're able to use that asynchronous DR using PXDR in order to schedule movement back and forth of your applications if you want to. And again, keep in mind, it really doesn't matter on the platform. You could be using OpenShift, you could be using vanilla Kubernetes, EKS. It really doesn't matter. You can migrate those full application sets, including all those objects, to a destination cluster, and vice versa if needed. So again, having Portworx as that data platform on your Kubernetes cluster really provides that flexibility and the features that you simply won't be able to find anywhere else. So that concludes what I had to show you today. Again, go up, take a look at our website. We offer Portworx Essentials, which is a forever free version. Really great to get you started, maybe run some of your small production applications, get familiar with Portworx. We do offer a free 30-day trial of Portworx Enterprise. So, again, you can go up, take a look at it, get your free 30-day trial. That unlocks all of the features in our enterprise solution. We do offer monthly pay-as-you-go or annual contract options for Portworx Enterprise. And then I really encourage everybody to go look at PX Backup, because compared to a lot of the other backup and data protection solutions that I've used personally out there, when you combine this with our Portworx data platform for Portworx Enterprise, it really does give you a flexible and great option for doing all of your backups and restores of your Kubernetes data and applications and objects. So let me check the chat here. Fully compatible with Google Anthos. Yes, we do support Anthos, Julian. You are welcome. Okay. Well, I just want to thank everybody for joining us here today. We've got one more hand. Julian, let me try to unmute you real quick, okay? Okay, try now.
Thank you very much. I have
Sure.
a question. If we compare Portworx, for example, disaster recovery or migrate with the kind of migration some services provide, for example, in this case, PostgreSQL, do some logical replication, for example, how do you compare these kinds? Portworx is easier to use, but is it the same like service at the end? So, for example, for the latency of the replication of the data, etc. Can you compare like using service replication instead of data replication? I'm not sure to be clear, perhaps.
Could you define service replication? I mean, we're
for example, the logical replication in PostgreSQL, for example, master slave.
Okay.
For example,
So you're talking about having a replica set with multiple replicas of Postgres and having that spread out. Sure.
Yeah.
Again, that's fine. We can work with underlying replication strategies for things like Cassandra or Postgres just fine. One of the benefits of Portworx is, let's say that you have those underlying data volumes that you want to simply replicate across multiple nodes within a cluster. we can still piggyback on top of that service replication, as you're calling it, for your databases. And we'll work just fine with that, and we'll actually provide you better HA for those underlying volumes within that replica set for your database. So we're very flexible. We can work either way there. If you choose to do replication at the application level, we work just fine with that as well. So it's really going to be up to you with how to architect that and how to deploy that for your application needs.
Okay, I got another question if you have time.
Sure, sure.
It's about scaling. You scaling. So you talk about PX Autopilot that is able to scale. So can you explain us a little bit about how does it work? So do we have to activate it, and then, for example, he automatically gets some new volumes from vSphere, or, for example, in the cloud, any of the cloud storage or disk? How does it work precisely? So
Sure. So Autopilot is going to monitor. So all of our Portworx volumes, we support dynamic growth on. Okay, so dynamic expansion, online expansion. So what's going to happen is Autopilot's going to sit there, and you can provide it. You do need to set it up front, okay, to say, hey, when you see, you need to tell it, hey, Autopilot, whenever you see this threshold start to get close, right? I want you to expand my volume by X% or X number of gig, okay? So Autopilot's sitting there in the background, constantly monitoring all of your PVs within a specific namespace or with a specific key value pair label that you've given it. And as soon as it sees those thresholds hit, it's going to go out and it's going to dynamically grow that volume and make sure that you don't fill that volume based on the specs that you give it within the Autopilot constraints. Okay, so it does need to be configured and set up front, but after that, it's just sitting there in the background monitoring and then going ahead and executing on those volume grows based on the information that you've given it.
okay, and so Autopilot is able to scale up and down or only up for the volumes?
That's a great question. I've never actually tried to scale down with it.
Oh,
That's a good question. I can get back to you on that.
okay, thank you very much. I have another question about the metrics. So how it is like the observability of the whole system when we have Portworx? I have seen that you use Prometheus. Do you have some
Right.
like specific dashboard to manage your PX different tools, so PX Autopilot, PX Backup? How does it work? Every tool just sends some metrics?
We do have our own metrics server and some dashboards for Prometheus. If you go up onto our docs and support site, you can see some of the information on how we utilize Prometheus and display those metrics.
Okay, thank you. Thank you very much.
Sure. Thank you, Julian. Okay. And Nigel, when Autoscale adds disks, are there any limitations? In terms of limitations, those are really defined by yourself and the spec that you provided Autopilot with, Nigel. Okay, well, again, I want to thank everybody for attending today. Again, if you have any questions, feel free to come to our website, take a look at our docs, take a look at our product. You know, there's a section where you can get in touch with the sales engineer. You know, again, take a look at our forever free Portworx Essential, or sign up for the free 30-day trial of both Portworx Enterprise or Portworx Backup. And I hope this was helpful to you, and look forward to hearing from each and every one of you in the future. Make sure to sign up for our next monthly demo, and looking forward to seeing all of you soon. Thank you, everybody.